All right, hi everyone. Thank you so much for coming to another NEARC community event. My name is Katie Grillo, and I'm the GIS Web Technology Specialist at the City of Cambridge, Massachusetts. And I am also on the NEARC Board of Directors as your immediate past president. So NEARC is the Northeast ArcGIS Users Group. We host two major conferences every year in New England plus New York region. So we have a one-day event in the spring, and that is coming up on May 21st, and we will be at Salem State University in Salem, Massachusetts. And then we also host a three-day event every fall, and that event is going to be October 27th through the 30th. In beautiful Burlington, Vermont. So hopefully you can join us at one or both of those conferences. But these community events are really designed for us to come together between those two conferences so that we can deep dive on a specific topic. We have some user sessions, we do in-person mappy hours, and then we also have a wonderful partnership with some of our friends at Esri. And so every couple of months, we try to do one of these Esri Lunch and Learn sessions. So today's topic, we are going to be talking about using data expressions in ArcGIS dashboards. And I'm going to pass it over to, so just our flow. So, for today, we're going to have a little bit of a high level overview from Tom Schwartzman from Esri. And then we have a couple user presentations that are going to show us kind of how you can take some of these ideas and apply them to your own projects and workflows. And then we'll give it back to Tom and he'll dive a little bit deeper into the nerdy weeds. And so we'll save most of our questions and answers for the end. You can feel free to put things in the chat, but we will have some time at the end for folks to unmute and have a bit of question discussion time. So, all right. Thank you, Tom. Over to you.
All right. So for better or worse, the nerdy, weedy part is also up front, just so you know. Let me share my screen. And let me make sure I pick the right, I don't know which one it is. I think it must be this one. All right, I got some PowerPoints, yay. And then we'll get into some real world demos by our users and also then afterwards by me. So we're talking about data expressions in dashboards, obviously. Mark and I both are from the Boston office of Esri, and you maybe know us from NEARC's past and present. And so let's get into it. Basically, I'm going to start here talking about Arcade because the whole idea of data expressions is to use Arcade to massage your data into some format that is useful to you in your dashboard. So I have to spend a little time talking about Arcade to do that. I will mention in advance here that there is in the Esri learning education stuff, there's some seminar type stuff like, hour-long videos and stuff like that. But there's also a 2-day course on Arcade if you're so inclined, which goes well beyond what we're going to talk about today. All right, so what is Arcade? You hopefully have heard of Arcade. It's sort of prevalent throughout the platform. It's a lightweight and portable expression language. It's a programming language. It's pretty lightweight. And if you've done any JavaScript programming, you'll see a lot of similarities to that. And any other programming, you'll see, a lot of the same sort of standard programming language stuff in there. And we'll see it. We'll see that as we go through. So in dashboards, we use Arcade in a couple different ways. We use it to process data on the fly. That's the data expressions piece. You can also use it to format and customize visualizations like lists and indicators based on attributes and things that you do in Arcade. And then, of course, anything in a web map for pop-ups or labeling is supported in the map inside of Arcade, inside of a dashboard, excuse me. Why Arcade? Well, it really lets us massage things from what we have, whatever it is, into what we need, right? And so we're going to use it to do that transformation. I don't know why that didn't, sorry about the subtitle thing. So what is, how do we write Arcade? Well, Arcade shows itself in lots of different places in the system, and each of those places has the ability to use what we call a profile. And a profile, arcade profile, gives us some context about where we can use it, you'll see that in a minute. What variables we have access to, what functions and things we can do inside of Arcade in this particular space, and then what we're going to return. And that'll make sense here as we go through these slides. So for instance, this is a giant matrix of all the profiles across the top. There's a profile for labeling, and there's a profile for geoanalysis analytics, and there's a profile for pop-ups, and there's a profile for field maps, etc. And then these are all the different execution contexts or places, products, whatever you want to say, where we can use that, and this is that matrix. So for instance, for dashboards, ArcGIS dashboards, that's the product. We only have access to the dashboards profile here. But when you're in, say, Pro, you have access to a lot more different things depending on what you're doing. When you're labeling, obviously you have access to the labeling profile, etc. So there's some constraints, like obviously you can't do everything everywhere. It doesn't make sense, and we'll see that sort of as we go forward here. Depending on the profile, you have access to some sort of system variables. And you can see a list of these here. They're not all available, obviously, in all profiles. For instance, when we're talking about doing labeling in a web map, we have access to the map. You see the map here, and say the scale of the current view, the map, right? But when we are doing something else, like using it in a field calculation, we do not have access to things like the map. There's no knowledge of a map in a field calculation. So this is a big list, but obviously only certain ones are exposed based on the particular profile that you're in. Okay? So you won't have access to the map if you're doing a field calculation, as an example. And then we group, this isn't that important, but we bundle functionality into these groups and these bundles here, and then the different profiles say, well, I have access to the core, the data access, and the geometry bundles. Not so important. It comes pretty apparent when you're building your arcade script what you have access to, because it shows you that. And the last thing is, what am I returning out of my arcade function, right? I could be returning a date or or some text or a number or a geometry. Or in our case, for data expressions, we're going to return what's called a feature set, a set of features that then can be used to drive other elements in our dashboard. So there are different things that you might be returning from your arcade expressions. And like any programming language, we'll go through a little bit of the basics, and I'm not trying to teach you how to program, but I just want to, like, if you've done any program at all, you're familiar with the idea of some variables hold text. If we look at the bottom here, like downtown, and some hold a number, and some can hold a dictionary, and a dictionary can think of as like these paired name and value pairs. So a dictionary has, like, this one has neighborhood is downtown, population is 23,000, etc. And dates and true false booleans and an array, which is like a list of things. And then there's some other things that are more specific. They're not sort of common language things, but more specific to ArcGIS, like features and feature sets and geometries. And the portal, that's like ArcGIS Online or your enterprise portal, right? And attachments, things like that. So these are all elements of Arcade. It also obviously knows how to do math, like 5 plus 3, or this variable times that variable divided by that variable. And you see some other things here, like mathematical operators, comparison operators. Does this equal this? Logical operators, this and that, this or that. It has some constants like pi and infinity and things like new line, et cetera, et cetera. So some things that are common to that language. It also knows how to, when you're writing arcade code, it has some of these things like conditional statements. So very common in any language, you could say, well, if this is true, then I want you to do this. Otherwise, else, do something else. That's a very if-then statement, very common. It knows that. It knows how to do loops. So if you have a set of records or a set of things that you need to loop through, or you want to count from 1 to 10, that's a loop. And it knows how to do that loop here. You can see this example where it's going from 0 to some max value, and it's going by ones, and it does something. And you can loop through or iterate through things like lists or arrays, feature sets, which have many features, dictionaries, which can have multiple things in them. And you can write your own functions if you want here as well. These are just common language things. Don't be scared. The reason I say don't be scared, even though this whole data expressions things is about arcade, is that there are a lot of examples, and those examples will help you get through if you're don't have any programming experience. In addition to those basics, you can, I'm not going to ask you to read this. This comes right from the online help, but you can see there are all these functions. Like it knows how to do date math. What's the difference between date 1 and date 2? You know, it knows how to do things around cosine and sine, and knows how to do geometry things, like are things intersecting? What's the length? What's the area? All these things. I'm not going to go through this list, obviously, but you can see in all these different sort of types of things, there's lots of functions. I want to concatenate strings. I want to see how long something is. I want to, you know, all kinds of things like this. So this is right from the online help, but you can just get a sense that there's a lot behind Arcade that lets you do a lot of cool things. Here's an example expression, which is really just building a string. We're gonna have this variable called label text, and it's equal to the feature that we're working on, and like in a pop-up, for instance, and the field neighborhood. So we're gonna grab from the feature, the field neighborhood. We're gonna trim it. Trim is a string function that takes any white space, like spaces off the front and back. And we're gonna add a new line, carriage return kind of thing. And we're gonna add the words population changed by, and then we're gonna take this other, well, I don't know where this has been defined, but some other variable called normalized pop, multiply it by 100, round it. The default is to round to 0 decimal places. So that's what this is doing, and a percent sign. So you can see here as an example, we're just building an expression where we're assigning this label text equal to these various pieces put together. And the plus sign, when we're talking about strings, is just adding strings together. Here's another example of, you can see we're grabbing from the feature, the total population in the 2010, 2020, and then we're going to calculate this normalized equal to the change kind of thing, or the percent here you see, right? And then we return, what are we returning back to be used? Something. In this case, we're going to return that calculation that we did. It's a number in this case. Right. And so a couple other things here. Arcade is case insensitive. Doesn't matter if you call something uppercase or lowercase and mix that up in different lines of your code. You can have comments in there. You can declare variables, and ultimately you return something. I got to say, there's a ton of Arcade examples, so don't be freaked out if like what I'm saying isn't doesn't mean a lot to you. All right, so that's my Arcade introduction. I know it was fast. There are some good resources and training to look at and learn about Arcade, whether it's the full course or just some blogs and other examples, etc. All right, so data expressions. What are data expressions? They are Arcade expressions, and they're used to return a feature set, a set of features, which we then use as a source for our dashboard element, right? A dashboard element could be an indicator, it could be a graph, it could be a gauge, it could be a list, whatever, pie chart, etc. We're going to massage some data, return a new feature set of features that we've changed in some way, likely, that are then used in the dashboard. And one of these data expressions can power multiple elements. So once you build it once, if you want, if it makes sense, you can actually use it in many different dashboard elements. And it gives us access to a couple of those bundles of functions. And you see that list here. But again, don't worry about that too much. So here are my slides on some examples. And I'm going to show some of these on my demo part, which will be after Bill and Erica. But here's an example. How many people, well, if you've ever done a survey, use survey 123, you may have had a question that has a multiple, lets you choose multiple answers, right? So in this case, there's this road condition survey, which I'm going to show you, and you can check off any or all of the road condition. It might have a pothole, it might have debris, it might be slick. I think that's it, those three. And so the answers that come back from the survey that are stored look like what you see in this table. When you select more than one, they're all put in one field with a comma. And if you chart that now in your dashboard, this is what you get, right? You get all the different combinations that someone may have chosen. I chose debris and pothole. Someone else chose slick and pothole. There's nowhere on here that shows me how many people chose pothole. This is, not a helpful chart, right? Well, it might be helpful, but to me, it's not helpful. That's not what I want. So we can use a data expression to massage this data into something that's more straightforward. We sort of split out all these ones with multiples and make a new set of records, a feature set that looks more like this, where it just says how many have debris, whether it's by themselves or in combination with something else, how many a pothole, how many slick, and then the chart is a little more meaningful, right? So here we can see how many people said slick, how many people said pot, etc. Does that make sense? I hope so. All right, so that's one example. Here's another example. I've got a bunch of weather stations. This is in Maryland, I think. And you can see that in this county field, there are many in any given county. And in my list, if I want to list those, right, if I truly want to list them individually, that's fine. And you can see here, this Anne Arundel County has multiple entries in my list, but I may not want to do that. I may want to summarize that by county. And I can't really do that without massaging the data a little bit. So we can use data expressions to group the original data by county and ask for some statistics like total rainfall or number of ones that have advisory. And we end up with something like this, right? So we now go by county. We get a total number of sites. We take not total, I said total, but average rainfall here. And then we get a count of how many of those had an advisory. And that list, besides being formatted a little bit differently and nicer, sums up really by county, gives us that nice summary. Okay, so that's another example of how we might use it. Here's another example, bringing data sets together. This is, for example, some data, or I don't think it's real data, maybe it is, but around vaccinations. And they live in 3 different distinct data sets. So we have a layer somewhere that's got Moderna, a layer or table for Pfizer, and another one for Janssen. But we want to bring those together so we can say chart them or do something with them. We can use data expressions to combine them into one feature set, that has a slightly different format where we add a manufacturer field, right? And then we get we add all those into one data set, one feature data set that then we can use in a chart or something like that. You might also need to do some calculations across multiple columns. So in your data, you might have like last week's data and this week's data, and you want to do some calculation to come up with a change or something like that. And so we can do something like that as well. And those are just some examples. So now I'm going to stop slides, obviously, and I'm going to turn it over back to Katie to pass around here, and we can see Bill and Erica. We'll come back and I'll do some of the demos and look at some of the things that I mentioned in my talk there.
Great. Thank you, Tom, for setting that sort of groundwork for the next section here. So now what we're going to do is pass it over. We have 2 different users. So these are real world demos where these folks are going to show some examples from the work that they do and how they use some of what Tom just showed us. So first, we're going to pass it over to Bill Toussaint, who's going to show us a little bit about a dashboard that he has for the Connecticut Department of Energy and Environmental Protection. So Bill, over to you.
Great, thanks, Katie. Thanks, Tom. Yeah, first off, my name is Bill Toussaint. I work for the Connecticut State Department of Energy and Environmental Protection, and I'm going to talk a little bit about our modernizing our Angular recognition program that we have. It's something that we did probably a few years ago. I'm going to just kind of give a quick recap about what was requested and what we did, and then the end result was a dashboard with a widget or a listing that has a leaderboard that we use in our crate expression. So I'll go through the whole process. So yeah, we were approached a few years ago by our fisheries staff about modernizing this Angular recognition program that they have. Folks in the public can reach out and contact the staff here at DEEP and submit any kind of catch information as far as recognition for a state record, first catch, or the youth program that I'm actually going to talk about more detail with the arcade expression. But it was a paper process that was done. People were submitting photos, actual photos. They were emailing stuff. They were calling in. So it was pretty not very organized. So we ended up going with the Survey 123 to kind of modernize that approach. So a little bit of the workflow was that we used Survey 123 to recreate the form. From there, we had a Power Automate flow that sent off emails to staff to say, hey, a survey was submitted. Here's some information about the survey and the catch, and they could reach out to them. And there was an email as well that was sent to the person that submitted the survey. It says, hey, your survey's been submitted. Someone from DEEP might contact you. From there was a staff verification app that we created in Web App Builder, which we'll probably end up redoing in Experience Builder soon. That was created a few years ago. So the Web App Builder app is a staff verification app where DEEP staff can go in, they log in with their credentials and look at the points that were submitted from the survey and verify those and make sure the legitimate catch information and legitimate submissions, and then verify those, and it would go off to the dashboard. And there from the dashboard, it's viewed publicly, and you'll see some of the widgets and some of the catch information. So I'm going to jump over to that and just show that workflow. Hopefully you can see my screen. This is the survey that we created. Again, it's pretty lengthy. There's probably 40 or 50 questions. This is the form that they had. Just basic information about the user, the individual, and some information about their contact. This is the program that we're talking about, some of the Angular recognition program, and there's the first catch, state record. Then this is the youth passport one that I'll show you in the dashboard that we use the arcade expression with. Some information about where the catch was, and then information about the fish catch itself. And then you can submit your photos here and some signature and witnesses and such. So from here, I mentioned the Power Automate flow. Once this is submitted, it goes to the flow where the email is sent to staff to talk a little bit about what was submitted in the survey, and then the other email goes to the survey submitter saying thanks for sending that, and DEEP will be in touch with any questions. A little bit about this is the Web App Builder application that we built for staff verification. All records come in as pending review, so they'll come in as red, so staff can kind of go in there. They have edit permission, click on the points, and basically I'm going to say, is it verified or not, yes or no? And then all verified submissions will go to the dashboard. And this is the dashboard. Again, we started this, I think, in 2021, and our first full years were 22 and 23. So all the information here with the map and all the records is all from those last couple of years. And then the dashboard itself, the leaderboard here was just for the year 2024. We reset it every year. So this wasn't in the original scope. The leaderboard just became so popular, we kind of added it in later. But you can see all the information, that's all the surveys of the last few years, 1,500, then broken down by saltwater and freshwater, and then the catches themselves, the types of fish, largest marine or freshwater, and as far as length and weight. And then you can zoom in, just the dashboard itself, and zoom into your favorite town area, click on it, it's interactive. You see the catch information, and then there's pictures too. Let's see, what else? The recognition program, first fish, lifetime, and then I mentioned the Youth Passport. You can see how popular it's been. So getting into the leaderboard here, again, it wasn't in the original request. It just became quite popular over the last couple of years, especially with the pandemic and people fishing more and being outside. The Youth Passport program started in 2012. You have to be 15 years or younger. There was 22 species total, and we had someone in 2022 collect or catch all the fish, so all marine and freshwater fish across the state. So it's pretty exciting. They were awarded with a certificate, some fishing poles, and a pin, some other stuff. So they get a prize, and then we found in 2023 we ended up doing 33 species, adding a bunch more. And I don't think last year someone got all the species or not, but it's increased the fish catch and people going around and participating in this challenge. So over the last year or two, we found out that surveys doubled in participation from the paper process and the slow process that we had to the survey 1, 2, 3, and then the staff verification and the dashboard. So just jumping in the dashboard and looking at the arcade expression on the leaderboard, just going into the settings. And again, you're not seeing a lot back to the leaderboard. It was reset this year for 2024. So obviously the fishing season was going to be busier in the spring and summer. So this will fill out a lot more as we get into the nicer weather. But the arcade expression is kind of short and sweet, simple, but effective. It's just a few lines here, but basically it's going out to our ArcGIS Online organization, pulling out the data layer here. And then we're reaching out to get the first name, the last name, and the recognition sought. Once we get the recognition sought, we're focusing on the Youth Passport Fishing Challenge submissions, and then basically on the year 2024. So when the year resets and we're at 2025, we'll go in and just change this, as simple as that. And then from there, we're grouping, concatenating the fields. They're separate fields for first name and last name. So concatenating those, putting them together, and then creating a count. So we're going to sum up all the catches from one individual for that year, and then just sort by descending count on the dashboard. So this is what you get. We ended up putting this last updated, just to keep us honest, we were called out by some families and other folks to saying, hey, I submitted something last week and it's not showing up. And you can see this was last updated Sunday. So we got to update those, or maybe there hasn't been submissions. So people can see when it was last updated. But again, simple and effective arcade expression. I'm happy to share with others if you want to make it your own. And if you have any questions, you can email me. I can put my email in the chat, but I'll pass it on to Katie. Thank you.
Great. Thank you so much for that, Bill. And I love how you use so many different types of ArcGIS Online applications to get to that end product with the dashboard. That looks great. Next up, we are going to pass it over to Erica Poisson. And she is from she's the Watershed GIS coordinator, who's going to show us an example of a dashboard and some expressions that she worked on. So, Erica?
Thanks, Katie. Thanks, Bill. We have a similar dashboard for our Quabbin Reservoir. The anglers love to see and compete with one another to see who's fished the most in a given year. So I can see why that's so popular. So today I'm going to just share a dashboard that supports one of our internal workflows here. I work for Massachusetts DCR Division of Water Supply Protection. So I'm going to share my screen. And is everybody able to see this?
Yeah, looks good.
Okay, so all of the information in this dashboard is managed by staff through a series of different tools in ArcGIS Online. Primarily Survey 1, 2, 3, Experience Builder, Field Maps. But staff wanted a way to easily kind of delve into the database to find information, get trends and statistics. So we created what I've kind of termed the data exploration dashboard, because it's really designed to just allow them to explore the database in an easy way without having to go into Pro and know how to apply definition queries and all of that sort of stuff. So we're using Arcade in a few different ways within this dashboard. So for the first is within this list. This is a custom formatted list using Arcade and HTML. So if I scroll down a little bit, let's see here. we can see how some things change. So you notice this card doesn't have a view project file link. This card has a different icon compared to this card based on the file status. This card has no last inspection date on it. So that's all being controlled behind the scenes with a series of arcade expressions and then some HTML formatting. And I find that it provides a nicer looking and more informative card that gives like at a glance information for a feature within our data set. We're also using Arcade to create this stacked bar chart. So this is taking data from 2 different feature layers, and it's bringing it together into one feature set, and we can see all the data as a whole. We can also filter it by watershed because we have added in that option into our new feature set as a new attribute field. But it just kind of brings everything together into one place. So, you know, if file CGP-WACH-003 has information in those 2 separate feature layers, I can bring it all together into one chart that makes sense, that shows all of that information. So I'm just going to hop over to just kind of explore this feature set. So if I edit, the first thing at the top here is this custom memorize function. So there are hundreds and hundreds of points within my data set, and I wanted to do an intersection between my points and the polygon layer so I could identify what watershed each point falls into. But because there were so many points, I mean, it took me like 5 minutes to open my dashboard as the expression was powering up in the background, for kind of lack of a better way to phrase that. I went on the Esri community site, and if anybody hasn't been there and you want to learn Arcade, this is a really fantastic place to come. Jay Carlson and there's another gentleman, Johan Linders, who are like really, really active in posting Arcade information. So anyways, I found Jay Carlson's idea and blog about improving performance for data expressions. And that is where my memorize function came from. And it increased performance. Like I can open this dashboard in about 30 seconds now, where it used to take literally like 5 solid minutes for it to open up. So this is up at the top. Next, I come down and I define my different input layers and their status, because each inspection can have a different type of status. So you'll see that we've got these 3 sources coming from the same layer. They just have different statuses: stable, unstable, general observation. And then we have these 2 groupings, which is a different layer within my hosted feature layer. They're all kind of related tables and that sort of thing. So after I've defined my data sources and my statuses, I load my polygon watershed boundaries that I want to use to run my intersection with my points. So here I call my memorize function from the top. I create a feature set. I define the item. I say I want the watershed name. I say, please use my geometry. And then I start by creating an empty array for my features. And this will be ultimately my feature set. So I have a loop here that's going to iterate over all of my input layers. It's going to intersect them with my watersheds. And I'm going to add new features to the array. And each new feature will have a file number, a status, and a watershed assigned to it. Here, I create a dictionary to create my feature set. And I combine everything, and then I'm going to group by my file number. And if I click run, hopefully that won't take too long. I can always just show you outside of this editor. Let's do that. So if I expand my data table here, this is what my resulting feature set looks like. You can see file number, point status, the watershed, and the number of inspections for each file. I did notice as I was reviewing this that I do have an error that I need to fix. So all of my revisits are coded as no watershed. So when I do apply my filter here, you'll notice if I reset it, so this file has 15 unstable revisits, but if I select by watershed, you'll notice all those disappear because I didn't appropriately define the watershed in my data expression. So I do have to go back and fix that. But this is a really nice way to summarize my data, bring multiple layers together, and stack it all up in a useful chart for staff to be able to review their work. And that was kind of all I was going to show. So Katie, I'll pass it back to you.
Thank you so much, Erica. So thank you to both Bill and Erica for sharing those demos. They both said that they would be comfortable with if folks had questions, we can address those at the end of our session today. But for now, we're going to pass it back over to Tom to show us a couple new demos.
Okay, back to me. This is just the arcade course I mentioned. It's just, if you go to the Esri training, you can search arcade, you'll find this. It's a two-day class. There are other online learning things that are part of are free to you, but this is a paid class. All right, so let's talk about some of the examples I showed or some other examples. So there it is. This is road condition, that pie chart we talked about, if you remember. So here's a survey that drives that. And here are those multiple choice, here's that multiple choice question. So you can pick more than one and submit, right? And if I refresh this, we should hopefully see that new record come in. I go to the bottom here. There it is right there, debris pothole. And let's go to the dashboard. I think it's probably already updated, but this is if we look at this pie chart, right? This is pointing at the results of the survey. And if we look at this one, you see it's just basically using that road condition field, which could have multiple answers in it. And therefore, that's why we see, debris slick, debris pothole, all the different combinations. But if we look at this one, it's been broken out. So let's just go over that a little bit. This is an example. By the way, I forgot to mention this, and this is a resource link that's in my PowerPoint, but also we'll share with you afterwards. On GitHub, there's a whole set of examples, and this is one of them, right? And it's not the split comma across; it's the split categories one. I don't know why that's not showing me the right one there. Oh yeah, it's just that's the right one. So okay, so let's look at the code. And I'm not gonna spend hours trying to explain this code, but just give you the general sense of it. First thing is to go out and find the item, the feature, hosted feature layer. In this case, that's its item ID. It's layer 0 in that hosted feature layer. I only care about one field, and that's the condition. I don't care about geometry, so that's why this is false. Excuse me, by the way, let me move this out of the way. I'll just point out, this is the arcade editor. And over on the right here, you can see the things that you have available to you. So we talked about profile variables, right? Sometimes you have a map, the map or the layer or the feature, et cetera, available to you. Within the context of doing data expressions, you don't have any of those things. You're not working on a specific feature, so that's fine. But there's also this thing about functions, and it lists all the functions that you might be interested in. And if you look at this, for instance, feature set by portal item, I'll just show you that one, feature set by portal item. There it is. It shows you how to use it. It gives you the help here. So if you look at it, you see that I'm gonna point it to my portal, which is arcgis.com. I'm gonna give it the item ID, the layer ID, the fields that I want. In this case, it's just that road condition, and then whether I want geometry. So you have this help here available to you. I want to point that out. Okay. All right. So we get basically that layer, but only one field from it. And then, as you saw with Erica, we need a place to put our new information. So we create an empty array, an empty list, if you will. And then we're going to loop through, that's this for loop. We're going to go through every feature in that feature set. Here's remember, FS is our feature set with just that one field. And we're going to do some things. We're going to grab that road condition field and we're going to split it. It's text, and we're going to split it based on comma. So if there's any commas in there, we're going to split up the thing into multiple results. So if it just says pothole, it'll return pothole. If it says pothole, comma, slick, it will return an array or a list that says pothole for one and list for the second one. We're going to see how many there are, and we're going to loop through those, and we're going to basically create a row in our new feature set for each of the things that we found. So we found debris, that gets a new row. We found slick, that gets a new row. And we'll add that to our empty, well, what was empty, to our list of features. So we're going through every feature in the result of that survey, splitting it up and adding a new row for any answers in that condition. Once we've done that, we have to create a dictionary that is basically the structure of a feature set. And that dictionary has three, well, I can have up to four things, but three things really. One is the list of fields. In this case, we just call it split choices, and it's of type string. We don't care about geometry, so that's blank. There's no geometry here. And then the features, the actual records, are what we created in this little loop. And then the last piece is we're gonna return we're gonna take that dictionary, we're gonna turn it into a feature set. And that's what this feature set function does, and we'll return it. Ignore this bottom piece. So if we look at this, and we can run this right here in this little window here, and you can see what it, oh, I must have, do I have that wrong? Oh yes, so here they are split out, right? So debris, pothole, slick, et cetera, et cetera, et cetera. And that's what we're gonna use in our chart. And also you can see here that you have this refresh interval. If you think this data needs to be like real time, you can specify in minutes how often it should run. Now be a little careful here, because if your thing does a lot of work, like Erica said, it took her 30 seconds at best, to do her data, munging there. If you run that every minute, that's not going to work, right? Well, it'll work 30 seconds, whatever, but why would you do that? That's very painful, right? So one, be aware of how complex this is and what it's doing, but also if you're going to use this refresh rate, be aware of that as well. So, all right, so that's what it does. This is what it returns, right? Which is different than what we saw at the beginning. If I just show you what we get here by just putting this in here, just so you see what it looked like to start. This is what we start with, right? And then you saw what we ended up with, where we basically split them out, right? Okay. And then the chart is fairly simple, because we just basically say group them by the, the different values that are in that split choices: debris, pothole, slick, and we get this. Does that make sense? Any questions on that? Put them in the chat, I guess. All right, so that's one example. Let's go to this next group here, and let's look at some of these other ones. Let's look at these lists. I mentioned, like, there's that weather station list here on the right, excuse me, is just the list as it comes from the layer. So we've got, the state, the county name, the station ID, the rainfall, whether it has an advisory, and you can see in Anne Arundel County, there's like a whole bunch of them, and in other counties, there's Baltimore City, there's 2, and in Baltimore, there's a bunch, whatever. If we want to summarize that to come up with something like this, it's 1 entry per county. Let's take a look at that code. All right, so this is a lot shorter. So we basically go to the portal and get our item. We're only interested in a few fields. This has a lot more fields in it. We want the county, we want the station number, how much rainfall, and whether it has an advisory or not. And so we're going to use this arcade function group by. And if you've done any SQL, that SQL queries, that maybe is familiar to you. We're going to group the feature set that we got from the layer based on, in this case, just one field, and that's county. And when we group, we want some statistics. We want to get a count of station number. We want to get an average of rainfall, and we want to get a count of anything that has an advisory, because they're blank or null if there's no advisory. And so we are creating 3 fields, one called total sites, one called average rain, one called count advisory, for each county. That is the count of stations, the average rainfall, and the count of advisories. And if you run that, ignoring the nulls that have no county name, you see there's only 1 entry for each county with a count. And you see the field names, right? They're what we specified. And the average and how many advisories. Okay. And that's what we're seeing here. I did filter out the nulls here so that we don't even need to see them. But that's the list, right? We grab the county, the total sites, the average rain, and that count. And in fact, remember, this feature set is driving this list. When we ask for what fields are available to us, you see the fields that the feature set created, or that our data expression created, right? So I didn't make it as pretty as what we saw in the example, but this is one of the examples also in that arcade. Okay, another one is bringing together those data layers. So we had 3 distinct data sets, one for Moderna and Pfizer and Janssen, and we want to bring them together so we can do something with them. In this case, there's a chart. So let's look at that. And we'll go into the code here. All right. So what are we looking at here? We're basically grabbing the feature set. Here's that item ID, layer 0, all fields, no geometry. And we're grouping it. So we're doing some summary as we bring it in. We're bringing in the Moderna, and we're summarizing based on how many, summing up this first dose, second dose, and total count. And we give them the names Moderna 1, 2, etc. We do the same thing for Pfizer. We do the same thing for Janssen. So now we have some summaries for all 3 of them, and now we just have to go through and sort of add them together. So here we create a dictionary that's going to hold our combined data set, and this is sort of the precursor to a feature set. It has a list of fields. It has a geometry type. And right now it has no features because we're going to add those features into this dictionary down in this loop. And so there are actually 3 loops here, one to go through the Moderna records, one for the Pfizer, one for the Janssen, but they all work the same. They're basically going to add a feature with the attributes of the specific manufacturer, the count of doses, and the things that we calculated up above. We do that for all 3. And we end up with this resultant dictionary that we turn into a feature set. If we run it, I think it does this by week or something, by date. So there's the different dates for Moderna and Pfizer and Janssen, right? And the count of doses and the week, etc. And then once we have that, we can then just put it in. It's just like any other data set that we might want to use to drive our data, our dashboard element. In this case, we're doing a chart here, and we're saying week of allocation on here. That's a date field that you need to, turn into a date field. That's fine. And then the category, sorry, the chart, missed that here. We're splitting it up by manufacturer, and we're summing up the count of doses. And you can see, you get this chart. So that's another example of how we might do that. The last one I'll just show, another one I'll show you here, not the last one, but another one. What is this? This is looking at the latest record from a data set. So you may have a table or a feature layer that just keeps getting added to every week with a new value. And all you want is to pull out that one last record. You don't know the date. You just want the most current record. So let's look at that code. This is pretty straightforward here. We have our item. We're going to our item. It's in layer 0. We're going to grab these fields, and we don't care about geometry. Okay. And then we're going to find the most recent date, and we're going to filter the record set to only return the record that has that date. So here we're using this function max. We're looking for the max of the date field, right? And we're turning a date, and we're turning into this little string, so it looks like this: year, year, month, month, day, day. And I'll just show you what that looks like if I do return max date. You'll see it here. So this is old data, of course, but the max date of this data set, the latest date, is April 27th, 2022. And then we'll use that date to filter our feature set. And we'll say date equals this thing that we calculated, max date. And we'll return that. And if we look at what it returns, it really, in this case, only returns one record with all the fields that we asked for, right? Or all the fields from the original feature set there. And we're just going to use that. So there may be, in the source data, there may be 1,000 records. We're returning one record that has the latest date. Okay. And then we do whatever we want with that. Like in this case, it's pretty simple. It's just showing us the people vaccinated. So that's just an example of how to pull the latest date. Okay, a couple more examples, and then we'll stop and we'll open up for questions. Okay, trying to remember. Oh, this one. Okay, collisions by hour. So LA traffic collisions in LA County. Most of these come right from the layers, but this does not. Because this collisions by hour, we have to massage the data because we don't have an hour field. What we have is a time field. And if we were to look at this layer, I don't think I have it up here. No. The time field is like just a number that says like 131 or 1215. It's not a proper time field. It's just a number that we have to parse. And we're trying to parse out or grab just the hour so we can use it in this chart. So let's look at that. Go into edit here. This is not too long. It's again, we're gonna basically get our item, and we're gonna filter it. You see the filter here. So we not only get it, but then we filter it, looking for a specific year, a specific day. But that's fine. That's not the important part. The important part is how we do something a little bit different. So we create an empty sort of feature set that we're going to add records to, and these are the fields that we're going to put in that: day, date, time, the area name, the premise, the description, and the record number. And we're going to capture the points as well. And it doesn't have any features yet because we're going to loop through and we're going to pull those features out. The only thing that's sort of interesting here, or the thing that's interesting here, I should say, is that we're going to massage that time field. Like if I show you what this looks like, let's just do, what we got here? What do we start with? We start with, what's this called? FS. So I'll show you what we start with. Return FS, just to show you something. Right, here's that time field I mentioned. It's just like this. Could even be a string, like 955, 415. 1900. Right? It's not really a proper time field. And we only care about the hour in this example. So let me get rid of that. So what we're going to do is we're going to loop through those records, and we're going to massage that time field that we saw and be a little tricky. So what we're going to do is we're going to take that time occurred, which is like 131, and we're going to export it or cast it into text with this format. Basically, I want 4 digits. The 0 is optional. The pounds are mandatory, and then or vice versa. And then I'm going to put a comma in between the first 2 and the second 2. So once I have that, it'll be like 01, 31, for instance. And then I'm going to split that. We talked about splitting when we talked about the pothole thing. Based on the comma, we're going to split it up. And then I'm going to grab the first piece of that split. That's what this is. So time occurred returns the split up text. It returns like an array with 2 elements, 01 and 31. But we only care about the hours, which is the first element, and that's element 0 here. So really, we're just grabbing, in this example, we're grabbing the attributes as they existed in the source layer, way up, way here, like we're grabbing DR number, date occurred, area name, premise description. We're going to each feature and we're grabbing them straight up and just stuffing them back into our new feature set. And the only differences are changing this time occurred to only be the hour. And if we look at what that looks like, look at the time occurred now, right? It's just an hour. Now you might argue that it should probably do rounding, like what is 158? Should that be 1 or 2? In this case, it's grabbing 1, but maybe it should grab 2, but whatever, it doesn't matter. Anyway, so now we have this hour field, and that's what's driving this chart. Okay, so we've done some massaging, basically creating a new field with the hour only in there. All right, one more. Oops. And that's this one, where again, we're in traffic here, and we have the age of the victim, any victims, but we don't want to have a continuous age, like 18, 19, 20, 21, et cetera. We want to group them into categories like below 18, et cetera, et cetera. So let's look at that code. All right. This is filtering, grabbing the item with these fields. It's layer 12 in our hosted feature layer. I don't care about geometry, and I'm putting a filter on this, and that is just between 2 dates, like basically the first 6 months of 2023. And then I'm going to create my output fields. You see here, don't care about geometry, don't have any features yet. And I'm going to go through every record, and I'm basically going to make a decision. If the age is less than 18, I'm going to give it this label of 1 to 18, and you see the rest here. And then I'm going to stuff into the features, not the age, but the age category. That's going to be this text, one of these bits of text here. And the rest will come straight from the feature, the premise and the sex and the record number, and we'll return that. So we go from something that looks like this, where the age is continuous variable, anywhere from, well, I don't know if it's really 99, but whatever, that, to something that then looks like this. Where we have this victim age category, right? And we've dropped the proper age, like the actual number. We could have left that in. We don't care about it, so we dropped it. And now we can obviously build that chart based on that new field called victim age. And that's what you're seeing here. All right. I'm going to stop there, I think, and ask questions. There's some other things I could show that Bill and Erica alluded to. They're not about data expressions, but they are about arcade and dashboards. But I'd like to stop and ask for questions, any questions that people might have about the data expression piece. And then if we have time, which we likely will, I could talk a little bit about some of the formatting things that you can do in Arcade as well. So I open it up. Any questions in the chat that came through, or anybody want to unmute and speak their mind? Here we are.
Thank you, Tom. I think so. Yeah, folks, you can put questions in the chat, or feel free to raise your hand, or even just unmute yourself and go for it. But I'm going to kick us off, Tom, because I noticed both in all of your demos and also what Bill and Erica showed us, you went into these different elements within your dashboard and you just clicked an edit button. But when I go into my dashboard, I don't see an edit button. So how do I even get started with adding an expression?
Great question. So let's go ahead and add an element to this dashboard. So I'll just say add an element over here. Don't care what it is. We'll just make it a list. And it says, all right, well, what's the source data? What am I going to use to drive this element? Well, here are the layers in my map. I could add some other layer if I had it, right? So I can add, other layers. But here's the data expression. And I could use existing ones, but if I want to add a new one, I just click that. And I'm put right into this arcade editor to edit this data expression. There's that refresh interval. Here's a link to documentation and those samples. The samples are what I mentioned on GitHub. And then you start writing code, whatever you're going to do, like, feature set equals get. Notice how it's auto-filling, which is nice. Get feature, I don't remember what it is. The portal item, find. I can't remember. But anyway, you can see, then I just start coding, right? And writing the expression that's gonna help, right? And I will just pop back to here just to show you, like, this is that GitHub site where we talk about dashboard data, and there are all these examples, some of which we've seen here, like split categories. That pie chart one is right here, and you could just copy this, right? Copy the code, the arcade code, copy, and go to your dashboard. I don't know what dashboard I was in when we were playing before, so I'll never find it. Where was I? I don't remember. Oh, here, right? And I can just paste that in, right? And so here you see, and you could, paste it in and then massage it, obviously to meet your own criteria. That's how you get started.
Great, thank you. There was a question that came into the chat. I don't know if Erica, if you want to unmute and explain things in any more detail.
I think that kind of covers it.
Can you read that question, or is there?
Oh, it was just a reference to the difference between stable and unstable visits.
Oh, right.
I think that looks, the description's in the chat.
Okay. Any other questions? Okay.
I always have questions for you, Tom.
Oh.
I'm also wondering, when you're in the editor and you're clicking that run button, or even when you set that interval for it to automatically run, does any of this cost me any credits in my organization? I'm thinking about how Python notebooks or data pipelines.
Yeah, there are no credits here. This is just an arcade expression that runs. You're not, the thing about notebooks and data pipelines that actually cost credits while you're, using them, is they use like a what's the word I want to say? Like a container that's running a whole separate, like, Python engine or whatever it's running in the background that uses, CPU resources that basically have to be paid for, right? But in this case, we're in our browser, and Arcade is running in our browser, and it's just like if you were editing in a web map, if you're editing a pop-up and you're editing the some arcade aspect of a pop-up, there's no cost to doing any of that.
Can I kick in just my 2 cents here as well?
Sure.
So one thing that I have noticed with some of my dashboards, it depends on the data you're using and how much data there is being run through your data expressions. But I'm working on a dashboard now. It's really just a series of tables being powered by a data expression. But, my dashboard has maybe 5 tables where this is happening. And some of my end users have commented to me that their browser just crashes out because all of those expressions are kind of loading when they open the dashboard. And the common denominator we've noticed for them is that they have i5 computers, whereas I have an i7 and I never have that problem. So it's also something to kind of keep in mind who will be using it and maybe what kind of computing power they have available.
Yeah, that's a good comment. I'll give another comment. There are times when this is not the place to combine and massage your data, right? Like you said, Erica, without that memorize function, you're 5 minutes, and even 30 seconds can be, unacceptable. So you possibly will come up with places where you just can't, it doesn't make sense to do it here. And that's when you should think about doing it outside, if you can, outside of the dashboard, whether that means using a Python notebook or data pipelines, which is a new sort of data massaging toolkit, or some other method to do it. In fact, here's an example. I was talking to a colleague who had a customer who had sort of like inspection records on some, whatever, the towers, I don't know, water tanks, doesn't matter. But instead of having like a feature layer of points for the locations and then a table of inspections, what they had was the points, but every time they did inspection, they just collect a new point on top of the old point, right? And basically they had to do all this massaging. Well, we tried to do it in arcade in data expressions to sort of basically simplify that into a point with related records, and it takes like 5 minutes, right? Which is unacceptable. No one's going to wait 5 minutes. Now, had they formatted their data such that they had the related table with inspections and the or the table with inspections and the point layer, you can in the portal in ArcGIS Online or Enterprise, you can create a hosted view. And when you create a hosted view between say the points and the inspections, you can say that you only want the first match, and you want that you want that match to be based on a sort by like by date. So you only get the current inspection for any given point. To do it the way they had it with the points on top of each other was unusable, but had they had their data formatted differently, then they could have done a join in ArcGIS Online or Enterprise, which will take care of that in the data at the database level. And then the results are, basically that to load that is like 3 seconds and not 300 seconds, right? So if you find like this is a fairly complex and lengthy, you're doing a lot and it's taking a long time, think about where else or how else you might combine your data such that it's not done in data expressions. That's just a reality, right? I mean, you can only do so much here in Arcade and have it be reasonable. Any other questions come up? All right. Well, let me just show, I know we have a little time anyway. Let me show something that both Bill and Erica had in there. That's not it. Is it this one? Nope, that's not it. Bear with me. This one. This is just a copy of Bill's dashboard. Do you know you can make a copy of someone else's dashboard if they've not turned that off? Anybody know that? That's pretty well documented, but basically what you do, if you find a dashboard you like let's just take this dashboard. I'm going to show you this. Oh, this one might not be public, but basically what you do is you go to the dashboard URL and you basically say /new #ID. Oh, I did it wrong. This is documented. So it's new #ID equals this. Okay. And if I hit return, which I'll do in a second, it's going to say, oh, you want to create a copy of this dashboard? Give me a new name. And assuming you can turn that off, by the way, like if you're the owner of the dashboard, you can shut this off. But if I do this, here's what I get. Oh, you want to create a new dashboard from this other dashboard? Sure, I'll do that for you. Right. And then you can you can actually, edit your copy and see what the heck they were doing. What was that data expression they used? How did they format that chart, right? So this is a handy thing to know about. So again, it's dashboards/new #ID equals, and then the ID of the old dashboard you want to copy. And again, it may not work for all dashboards because you can shut off that ability as the owner, but many it will. All right, so I just want to show you this. This is bills, and you see a copy of bills, I should say. This is what we saw with the data expression, but I just wanted to point out this is a pretty simple one here. We're doing something in terms of formatting this these values. So let's look at what that means. When you let me show you one thing here. When you add a new list, and I'm going to use lists, but it applies to more than lists. I'm going to add this new list. Doesn't matter what I pick here. Just want to show you something. There's this option under list called and some other of the data dashboard elements that says advanced formatting. Okay, and it lets you really tweak what's going on. So if you enable that, you're put basically into, ta-da, what does this look like? It's the arcade editor, right? Because we're going to use arcade to do that. So I'm going to go back to this list that that was formatted, and I'll go here to list, and let's bring this up. So this doesn't do very much. All it does is it formats, like takes the length in inches. This is fish, remember, fish catch. And it formats it in this nice way. And also the weight only to 1 decimal place. That's what you see here. And then for the length, it does something a little tricky. It grabs the, let's say the length is 21.25. So in this case, it'll grab the 21 part. That's the floor. That's an integer function that grabs the number. And then it subtracts that 21 from the actual value to give me like the remainder, like 0.25. And then I say, well, if that remainder is 0, then we're done, right? The length that I'm going to return here is just 21. But if it's 0.5, I'm going to add to it this little, it's hard to see, but that's the little half character. And then here's quarter and here's 3/4, right? And then that new thing that I just calculated called len1, right? Len1 is 21 plus either nothing, if it's a 0, or half, quarter, 3/4, because I only return values in these quarter inch increments. And then you'll see here that I'm going to return from this advanced formatting a new attributes, or 2 new attributes. One is the length that I did with these halves and quarters, and one is that weight, which has been formatted with 1 decimal place. Now, also notice that I've can do whatever arcade stuff I want to affect the color of the text. This is for lists, the background color, the separator color, the selection color, the text selection text color, etc. So if you look at this, if we go down to the actual list, this is just HTML, which grabs that length, and you see where there are halves and 3/4 or whatever, there only halves here. You see actual. That's just a nice way to make this prettier, right? Like I'd rather see 41.5 than 41.5 or 41.25 or whatever it is. That's one example. And the other, just to show you, I won't do this, but just to show you how robust this is, let me add an indicator. And I don't care because I just want to show you this. I'm going to go into the indicator. I'm going to enable this, and I'm going to show you this. Now I can do whatever arcade I want to figure out colors and math and do whatever I want for this indicator. But look at all the things that I can return from my arcade. I can change the text color, the background color, the text at the top, at the color of that text, the outline color. I could go on here. The middle text, which is the main meat of the indicator, its color, its outline, its size. Bottom text, the icon, if you have an icon showing, you can change it on the fly. So if the numbers say less than 0, I can make the icon red. And if it's greater than 0, I can make the icon green, all based on some arcade calculation that I might choose to do or whatever. And I can also return extra information if I want to use that. So I'm not going to do that because I don't really have anything to do, but I, you know, I could do that. I could say, you know, if, let's just do this real quick. If, let's get back in here, sorry. If the data point dot something, some field, whatever, is greater than 1500, if that's true, then let's make this color equals red, else green. And then we'll just change this color. We'll return the color to be this thing I called color. I have no idea if this will work. Oh, look, it's over 1500. It turned red, right? If this were less than 1500, it would be green. So I'm driving the formatting, the look of the feel of this based on arcade. Okay. So that's more about formatting, not about data expressions, but it is arcade and you can do really cool things here based on arcade. Yeah, and I'll stop there. I think I'm done. Any more questions? I'm happy to take them. And I also have a slide. I didn't show this slide. Let me just bring it up. With resources. So this has the arcade documentation, some links about what's new, introduction, some blog posts from which I took some examples. Here's that GitHub reference to the dashboard examples and some other blog posts as well. So these will be in what, you know, you'll get these links, so you don't have to write them down or anything like that. But as I mentioned, training courses in arcade, other things like that. There's probably some stuff around dashboards as well. So I will stop there.
Great, thank you so much, Tom. There was one other question that came through the chat. Rupsha was asking, how do I turn that feature off? Erica did put the description in there that you'd go into the item details for that dashboard, and under settings is where you can change that.
Right, that's right.
But I'm curious, did Bill know that you could do that?
Well, it is public, remember that, you know, I mean, so.
Yeah, I left it open, but.
Yeah, that's great. I think
Yeah.
it's a good thing to keep in mind though, that if it's open by default for folks to know.
So
if
settings, here it is. Where is it? Here, allow others to save a copy. Right. I don't think you can change that default, sadly, but certainly can shut it off.
All right. Well, with that, I think I'll say thank you so much to everyone for coming, for joining us today. Thank you to both Tom and Mark Scott from Esri behind the scenes helping with support. Thank you so much to Erica and Bill as our guest speakers from the user community. And hopefully you all saw the survey that we put out. We wanted to get some feedback from you all about different topics that you'd like to see in these. So if you have any sort of Esri topics or user topics you want to see in the future, please feel free to reach out to me and we'll see what we can do about getting that scheduled. If you're interested in Mappy hours, then all you got to do is pick a date and a location and send that over my way, and I'll help you to promote it out to the wider community. That's why we just had a Mappy hour in the Boston area that was actually set up by just somebody in the region that wanted to go out for some drinks. So these events really are designed for you as our user community, and we want to encourage you to have some ownership and involvement in that. So any questions, comments, that kind of thing, you can reach out to me. And you will all have my email address because I will send you a follow-up with the recording link as well as Tom's presentation and links to resources and other demos and things that we saw today. So thank you all so much, and hopefully we'll see you again soon.